And welcome everyone. Thank you all for tuning in to this special event with How to Academy. Joining us tonight is Professor of Science at Harvard University, Avi Loeb. As a renowned astrophysicist, Avi was the longest serving chair of Harvard's Department of Astronomy and is the founding director of Harvard's Black Hole Initiative. He also serves as a member of the President's Council on Science and Technology at the White House. In this talk, Professor Loeb will take us inside the thrilling story of the first interstellar visitor to be spotted in our solar system. He will be taking questions at the end, so please write your questions in the Q&A box at the bottom of your screen. Without further ado, it is my pleasure to welcome Professor Avi Loeb.
Thank you very much. Let me share my screen, 1 second. It's a pleasure to be in the UK today. I was on the Sunday brunch program this morning on Channel 4, and now I'm in London without moving from my home office. Okay, so this talk will be dedicated to my new book that came out about 10 days ago. And if I had to summarize it in one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. And this was the main theme of a Scientific American essay that I published a few months ago. What you see on the left is a photograph of a photograph that was presented in Berlin a few months ago by a famous photographer, Herlinde Quilbel, who asked me to write on my hand the most important question that I can think of in the context of modern science. And I wrote, "Are we alone?" And that's pretty much the focus of my book, Extraterrestrial. So let me start by making the case that we should be modest, which is pretty much the message I received over the past few decades when I worked on astronomy. I wrote more than 800 papers on the universe, and the message that we get from the universe is be modest, be humble. And so let me read an excerpt, 2 paragraphs that were inspired by my parents who passed away over the past few years. My father, David, was laid to rest in the same red soil in which he planted trees all his life, in the vicinity of those plantations that he watered routinely, near the house that he built with his rugged hands, and that I grew up in, surrounded by people he loved and who loved him in return, under the blue sky that I study as an astronomer. My mother, Sarah, who put me on the road to thinking as a philosopher, with whom I spoke daily throughout my adulthood, and who especially gifted me with the life of the mind, was buried beside him 2 years later. In astronomy, we realize that matter takes new forms over time. The matter we are made of was produced in the hearts of massive stars that exploded. It assembled to make the Earth that nourishes plants that feed our bodies. What are we then, if not just fleeting shapes taken by a few specks of material for a brief moment in cosmic history on the surface of one planet out of so many? We are insignificant, not just because the cosmos is so vast, but also because we ourselves are so tiny. Each of us is merely a transient structure that comes and goes, recorded in the minds of other transient structures. And that is all. Now, what I find quite surprising is that in human history, there were many that felt arrogant. They felt very powerful. Usually they were alpha males, like the one depicted in this painting, who conquered a piece of land and felt very proud of themselves. But the truth is that there are more habitable Earth-like planets in the observable volume of the universe then there are grains of sand on all beaches on Earth. So how can anyone be arrogant based on accomplishments on this single grain of sand? We know that about half of all the sun-like stars host a planet of the size of the Earth, roughly at the same separation. So it could have liquid water on the surface and the chemistry of life as we know it. All of that argues that we should have cosmic modesty. And clearly that's not what humans exhibited over history, starting with Aristotle, the ancient Greek philosopher, who argued that we are at the center of the universe. And for 1,000 years, people believed his philosophy because it flattered their ego. And then Copernicus and Galileo demonstrated, no, we are not at the center of the universe. Actually, the Earth moves around the sun. That was a shock. Initially, the philosophers did not want to look through Galileo's telescope. They put him in a house arrest. But the Earth continued to move around the sun. Reality doesn't care if we ignore it. And so all these emperors and kings that conquered a piece of land on Earth resemble an ant hugging a single grain of sand on the landscape of a huge beach. It's not very impressive. We must be modest. But I can understand why people are not modest. My two daughters, who you can see in this image, when they were young, they tended to think that the world centers on them, that they have special qualities, they are unique. But when we brought them to the kindergarten, they met other kids and developed a better perspective. They sort of matured. And our civilization will mature only by finding others around us in our neighborhood. We're probably not the sharpest cookies in the jar. And, I conclude that based on what I read in the news every day. We make a lot of mistakes. We invest a lot of time and effort and funds on destructive measures. And the sign of intelligence is promoting a better future for everyone. And by the jar here, I mean the Milky Way galaxy, our own galaxy. But there are trillions of Milky Way galaxies in the observable volume of the universe. So even within our galaxy, I don't think we are very special. One thing to keep in mind is Earth is our home, but only for a limited time. There could be risks from internal threats, such as climate change, non-conventional wars, pandemics, politics, or the technologies that we develop. They could lead to self-inflicted wounds. And then there are external threats. 66 million years ago, we know that the dinosaurs went extinct. Not only them, but 3/4 of all life forms on Earth. And that was because of a rock. It must have been a beautiful view for them to see this rock getting bigger and bigger on the sky. But the fun stopped when it hit the ground. We can avoid that, even though we don't have bodies as large as those of the dinosaurs. We have the human brain, which apparently is more useful for survival, because you can ask astronomers to look at the sky, use their telescopes, and warn us when a giant rock is heading our way, and then we can perhaps deflect it. But there are other risks from the sky. The final one is the sun warming us to the point within 1 billion years, it will basically boil off all the oceans on Earth through a greenhouse runaway process, similar to that that happened in one of our nearest planets, Venus. So let me tell you a little bit about my story, my background. I was born on a farm and used to collect eggs every afternoon. You can see that in the second image from the top left. That's me collecting eggs. We had chickens. And then the next image shows me sitting next to my sister on a tractor. I used to drive a tractor to the hills of the village and read philosophy books. I was mostly interested in philosophy because it addresses the most fundamental questions we have. If not for circumstances, I would end up as a philosopher. But in Israel, I was born in Israel, and there is obligatory military service, and I preferred to do intellectual work rather than run in the field. So I was drafted to a program where you get a PhD or you do research in physics that could be useful for the defense of the country. And I was privileged to finish my PhD at age 24 and lead a project that was funded by the US during the Star Wars initiative that was initiated by President Reagan in the mid-1980s. That brought me to the US and ended up visiting Princeton and got a 5-year offer there for a fellowship under the condition that I'll switch to astrophysics. So I had to learn the vocabulary. I didn't know how the sun shines. And for 5 years, I learned the vocabulary, and then I was offered a faculty position at Harvard and was tenured 3 years later and became the chair of the Harvard Astronomy Department a decade later. I was the longest serving chair over the past decade for about 9 years. And you can see my family on the right, my wife and 2 daughters. One of my blessings is that I'm surrounded by women. And then in 2015, an entrepreneur from Silicon Valley came out of a black limousine in front of the Center for Astrophysics at Harvard and entered my office. His name is Yuri Milner. You can see him at the bottom left. And he asked me whether I might be interested in leading an initiative to visit the nearest star, which is Proxima Centauri, about 4 light years away, within our lifetime. And since Yuri and I are the same age, what it meant is within 2 decades or so. And that means, because the star is 4 light years away, it means a spacecraft that moves at 1/5 of the speed of light, which is a very high speed, about a factor of 1,000 higher than anything we accomplished before with conventional rockets. So I told Yuri I have to think about it. And then for 6 months, we looked into various possible technologies with my students and postdocs and converged on one that I'll describe in a few minutes. And then we announced it in April 2016 as Project Starshot, the Starshot initiative, in the presence of Stephen Hawking, that came especially to New York City and Harvard for that purpose. So here is a picture of the solar system. On the left, you can see the sun and then the Earth. And at 10 times the Earth-Sun separation, you find Saturn. At 100 times the Earth-Sun separation, you find a place where the solar wind, the wind that comes off the sun, is stopped by the interstellar medium, the gas that fills the voids between stars. But the solar system goes beyond that. There is the so-called Oort Cloud, which is a spherical region that includes icy rocks, sort of like Lego building blocks that were left over from the formation process of the planets. And these icy rocks extend all the way out to about 100,000 times the Earth-Sun separation. So it goes all the way to half the distance to the nearest star, Proxima Centauri, or the Alpha Centauri system that has 2 other companions to that star. And what that means is that if other stars have Oort clouds just like the sun, these Oort clouds are touching each other. They are densely packed, just like billiard balls that are touching each other. And that means that if a star is passing near the solar system, it can rip apart some of these rocky objects and bring them into interstellar space, and since they are loosely bound. So naturally you would expect interstellar objects, objects that are in between stars, to be those rocks that are ripped apart from the Oort clouds of stars. And if they get close to a star like the sun, since they are covered with ice, they should appear as comets. The ice would evaporate and produce a trail of gas behind them. This is an artist's illustration of Proxima Centauri, which is a dwarf star, about 12% of the mass of the sun. In fact, most of the stars in the Milky Way are much smaller than the sun. It has roughly half the surface temperature of the sun, 3,000 degrees, and it emits mostly in the infrared, in difference from the sun that emits mostly visible light. That's why we have eyes that are sensitive to visible light, because for survival that was very helpful. But near Proxima Centauri, if there are any living creatures, they would have infrared eyes. And there is actually a planet in the habitable zone around Proxima Centauri, just at the right distance, about 20 times closer to the star, because the star is fainter than the sun. And it orbits the star every 11 days. So if there are living creatures there, they celebrate a birthday every 11 days. There must be a lot of parties over there. And the planet is so close to the star that it has a permanent day side and a permanent night side. It's tidally locked, just like the moon is to the Earth. But that may explain the fact that it's mostly infrared light that gets to the permanent day side, may explain why interstellar tourist agencies never advertise the Earth as a desirable destination, because most of the creatures in the Milky Way galaxy are used to infrared light. They have infrared eyes, and they would like to have, for their vacations, they would like to have dark red grass in the vacation sites. And they would never come to Earth, because they would say, this visible light is uncomfortable. We are not interested in green grass. I should say also that my daughters argue that if we ever go to Proxima b, this planet in the habitable zone around Proxima Centauri, they would like us to have a house in the strip that separates the permanent day side from the permanent night side, because there you can watch the sunset forever. So that's the place where the real estate value will be the highest. So how do we get there to find whether Proxima b has life? That's the challenge that Yuri Milner posed. And the only technology that seems feasible at the moment is that of a light sail, which is basically the same idea as a sail on a boat, which is pushed by wind, except here it's pushed by light. And in order to get to a fifth of the speed of light, one needs to use a very powerful beam of light, a laser. And so the idea is to have 100 gigawatt beam, very powerful, shining on a light sail that has roughly the size of a person, a couple of meters, and pushing it over a few minutes across a distance that is 5 times the distance to the moon, to a fifth of the speed of light. And that is possible if the sail weighs of order a gram. And one can attach to the sail electronics, the kind of miniaturized electronics you find in a cell phone that doesn't weigh more than a gram, that includes a camera, navigation device, and communication device. The technology of a light sail was already demonstrated. For example, what you see on the right side is a light sail 2 that was deployed by the Planetary Society in 2019. So here is a video that shows the concept. A mother spaceship releases a sail above the atmosphere so that the friction with the atmosphere will not slow it down. And then a laser beam is produced by a combination of low power lasers. And then they are focused on the sail and push it over a few minutes to a fifth of the speed of light. And one can repeat this process every day in principle. So one can launch a lot of these sails. They don't cost much. Most of the cost is in the infrastructure of the laser. And then the sail would continue along its journey. It's being launched for a few minutes and then it spends 20 years until it reaches its destination. It's relatively boring for 20 years until it gets close to Proxima Centauri and its planet Proxima b. And then the camera on board will take a photograph of the planet so that we can tell whether there is life on it. And this photograph eventually will have to be beamed back to Earth. That will take another 4 years for the signal to get to us. So it's a long trip, altogether 24 years. And also when the beam reaches us, it will spread to a spot that is larger than the Earth-Sun separation. So we would need a very large telescope to detect the signal. So this is the concept. And as far as I'm concerned, one can search for primitive life on Proxima b, but really the most interesting question is, are we the smartest kid on the block? Is there intelligent life that is more intelligent than we are? And my guess is probably yes, because if you open recipe books, you see that out of the same ingredients, you can make very different cakes. So imagine the early Earth and its soup of chemicals. What's the chance that this soup of chemicals was put together to make life as we know it in the optimal way so that we are the best possible cake? The chance is quite small if that happened by random processes. And it's quite possible that on other planets you have better outcomes, cakes that taste much better.